on to the last lecture for this lesson, this topic even. Solving trig equations with multiple solutions and the double angle. Okay, so there's a lot going on here. So we're asked to solve the equation cos 2x plus sine 2x when it's equal to -1 between 0 and 360. Okay, so notice here there's a 2x, right? So let's write that expression. So I'm going to use cos x minus a equal to k cos x cos alpha minus plus even k sine x sine alpha. Perfect. And then get my coefficients, k cos alpha and k sine alpha both equal to 1. K is going to be equal to √2 because 1 squared plus 1 squared square root is 2. Okay, and alpha is going to be equal to tan of 1, which I know is 45. And then think about the quadrants, both positive, first quadrant, so that leaves us with √2 cos 2x, remember the 2x, minus 45, okay, equal to -1. So we have this here now, right? So what we're going to do here is think about the quadrants again, right? So for this this term, well, we'll bring the √2 over first for simplicity's sake. So cos 2x minus 45 is equal to -1 over √2. Okay, so this is going to be a negative cos value, so it's not going to be there, not going to be there, is going to be there, is going to be there. So it's in the second and third quadrants. Okay, so is it just going to be in the second and third quadrants though? Kind of, yeah. But what you need to remember is because of this 2x, it's going to be 2 repetitions, 2 oscillations in the normal 0 to 360 space. So it's almost like it's going to happen in those quadrants twice, if that makes sense. I'll show you the graph afterwards. But for now, we're going to keep going. I know that cos 1 over √2 is also equal to 45. Cos inverse 1 over √2 is equal to 45. Okay, so I'm going to write it all over here. If you take these both sides, this becomes 2x. Yeah, it's easier. I need quite a lot of space for this. So 2x minus 45 is equal to, so first of all, the second quadrant is 180 minus 45. Okay, the third quadrant, which is 180 plus 45. Okay, then we go all the way around again. Okay, so now we come back to 180 minus 45, but it's happened in the second repetition, so it's going to be plus 360. Okay, and then again 180 plus 45 plus 360. I hope you're not getting confused by there's being so many annotations here. Just often I see there's no working at all, so it becomes really confusing. Okay, so let's go. So this then becomes 135 225 495 and 585. Great. Okay. Then what happens is, so So this is still 2x minus 45. You then bring the 45 over into each one, and you could have skipped this step, it could have cancelled it, but sometimes it won't be a nice number that cancels, but for the sake of this question, it's a nice number that cancels. So 5, 40, and 6, 30. Okay, cool. So are we done? Not quite. We're not quite done yet. We've still got one more part to go, and that's this 2x. Okay, so we need to think about it. Because this 2x is happening at twice the frequency. Okay, so we need to divide by 2 to get our points. So this becomes 90. This becomes 135. This becomes 270. 270. And this becomes 315, and that is our final answer. There's 4 solutions, okay? Not just 2 solutions, there's 4 solutions. So let's see what this would look like on the graph. So again, here's our cos 2x plus sine 2x graph, right, in red. And again, same in purple, same graph in the same form. Just proving that these things are equal to each other. So what I'm going to do now is, so this is between 0 and 360, and this line is at -1. So if we look at all the points where this graph crosses that line of y equals 1, they're like we calculated. They're 90, 135, 270, and 315, okay? So we need to divide through by 2 to get these exactly right, this exact answer, okay? Because you need to think about this graph as being repeated twice.